Now we're going to take a look at and study the concept of hypothesis testing. And how about if we start here, where we say that the main work of a statistician is to draw inferences about a population based on information obtained from samples from that population. For example, for healthy adults, the mean pH of arterial plasma, blood acid, is 7.4. Now, a new drug for arthritis has been developed, but it's thought that that drug may change the blood's pH level. Then for 3 months, 31 patients who took this drug had blood tests, and the blood test showed a mean now of 8.1 and a standard deviation of 1.9. Right, so the standard down here on the left is 7.4. That's for the entire population. We take a sample of 31, and now we're at 8.1. So based on information in this sample, a statistician would like to infer something about the mean pH of blood plasma for all arthritis patients taking this drug. So has the drug increased the pH, decreased the pH, or had no effect on the pH? So the statistician might be thinking, based on this sample, based on that sample of 31 patients, is there enough evidence to reject the claim that the average of the population is this 7.4? Some definitions to get started. First up is a statistical hypothesis. That's an assumption made about some parameter. So a statistical hypothesis is just some assumption that one makes about a parameter. For example, we might assume that the mean of some population is 7.4, or we might assume that the population proportion is 0.56. Now, a statistical test, that is a procedure that's going to lead to establishing whether or not there's enough evidence to reject the assumption. So a statistical hypothesis is an assumption made about some parameter. For example, we might assume that the mean is 7.4, and then we're going to apply a statistical test to see if there's enough evidence to reject that assumption. Here's an example of what we mean. Based on the other example that we just had, assume that the mean pH of arterial plasma for healthy adults is 7.4. That is, assume that mu equals 7.4. All right, that's the statistical hypothesis. Statistical hypothesis, an assumption, is an assumption made about a parameter. So make the assumption about the parameter. Assume that mu is 7.4. And now, based on the sample of 31, we get a mean of 8.1 and a standard deviation of 1.9. So we want to test this claim, test that claim. So that's what we're going to do. A statistical test is some procedure that we're going to go through which will lead to establishing whether or not we have enough evidence to reject this claim. Now, surely 8.1 is greater than 7.4, but is that difference just due to chance variation in our sample, because we only took 31 people, or is the difference more likely due to a real increase in the pH level caused by the drug? So the statistical test will advise us as to whether or not we can or cannot reject the assumption that the mean is 7.4. So we run a statistical test to see if there's enough evidence for us to reject the assumption. Now, some shorthand notation here. We're going to write H sub 0, or we call it sometimes H naught, N-A-U-G-H-T. So H naught, H sub O or H sub 0, whatever you like, H naught, this is the hypothesis being tested. We call it the null hypothesis because it's an assumption about a parameter, and we're trying to see if we have enough evidence to reject or nullify that assumption. So H naught, that's called the null hypothesis, and that's what we're testing. H sub A, or H1 if you like, H sub A for alternate hypothesis. So if we do reject the null hypothesis, we have to have an alternate to go to, and that's going to be this one. So in our example, we might write something like this. H naught, and then we write a colon, states that mu equals 7.4. So this is our assumption. We're testing this assumption. So H naught The colon reads states that. So H naught states that the mean is 7.4. And then if I do have enough evidence to reject that, I need an alternate hypothesis. And we'll write that like this. I'm going to use H sub A. I think the book might use H1, but I'll use H sub A for alternate. The alternate hypothesis might be this. Because of the wording of the problem, let's go back here. Back here down to the very bottom here. It says for healthy adults, the mean pH level was 7.4. Now, a new drug has been developed, but it's thought that it may change the blood's pH level. So it's just saying it's changed. It doesn't say if it increases or decreases. It just say if it's changed. So the way I'm going to write this one, just because of the wording of the problem, is going to be mu is not equal to 7.4. Now, just as a note here, if the problem said it is thought that this new drug may increase the pH-D level, then I might write something like this. Maybe I would write this. H sub A states that mu is greater than 7.4. So given H naught, we can make one of two decisions. We can reject H naught, or we cannot reject H naught. Now there's errors associated with each thing that we do. So suppose that we take a sample, and our sample indicates, here's our conclusion, suppose our sample indicates we reject H naught. But if it turns out that if H naught is really true, and we reject it, we've made what's called a type 1 error, right? We've rejected a true statement. Now, if we reject H naught, and in fact H naught is really false, we've made the correct decision. So if we reject H naught, but H naught is really true, we've made a type 1 error. If H naught is really false, then we've made the right decision. Now, if our sample indicates that we do not reject H naught, right, there's not enough evidence to reject H naught, and if H naught is really true and we don't reject it, we've made the correct decision, right? It's really true, we don't reject it. Good decision. But if we do not reject H naught and H naught is really false, right? We're failing to reject a false statement. That's called a type 2 error. So of course, down here now, when making decisions, we wish to control the probability with which we make errors. So what we're going to do is this. We're going to say that the probability of making a type 1 error, now just to remind us, what's a type 1 error? A type 1 error is rejecting a true claim, right? So if H naught is really true, we don't want to reject it. So we want that probability to be low. We're going to call that probability alpha. All right, this is the lowercase Greek letter alpha. And then we're going to say, all right, so the probability of a type 1 error, that's alpha. Probability of a type 2 error, that's going to be beta. That's a Greek letter beta. Now, type 2 error, let's just go back and look. Now, a type 2 error is this one. That is not rejecting something that's false. So if H naught is really false and we don't reject it, we've made an error, and we're going to... Now, because we can't do everything in this course, we're going to restrict our attention to these type 1 errors because they're probably a little bit more important to us than a type 2 error. If a new drug is developed, say, that cures some disease, we don't want to reject that. So we don't want to make a type 1 error, right? We don't want to reject something that really does work. So what we want to do is to keep this probability really low. But we need some kind of balance between these two errors. A type 1 error is rejecting something that's true. Now, if we don't want to reject things that are true, maybe we start accepting too often. And if we start accepting too often, then we're going to be making type 2 errors. So we need a balance between alpha and beta. And here's some frequently used agreed upon values for alpha. If alpha is 0.05, that means we can expect to make a type 1 error 5% of the time. Now what that means for us is that if alpha is 0.05, and we're going to choose the alpha, so if we choose 0.05, that means that we have a 5% chance of rejecting a true claim. On the other hand, if we choose alpha to be 0.01, that means we expect to make a type 1 error 1% of the time, or we have a 1% chance of rejecting a true claim. So this alpha, that is called the level of significance, and it is the probability of rejecting H0 when H0 is actually true. So we're going to end this unit here because we've probably done enough, and in the next unit we'll take a look at actually constructing a statistical hypothesis test.